Hello, welcome to Introduction to Java Programming. In this session, we are going to discuss about inter-thread communication. Inter-thread communication is possible with the methods such as wait and notify. Let's understand. So, inter-thread communication in Java. Inter-thread communication is also called cooperation, which is all about allowing synchronized threads to communicate with each other. Whenever threads are working in a synchronized environment, that means they are obtaining the logs and releasing the logs, then cooperation is important. That cooperation is also called inter-thread communication. The thread should be able to communicate with each other. Otherwise, other threads will actually starve. For example, in a reader's writer's problem, right? So reader thread is there and writer thread is there. And after writer thread writes the content, reader has to go and read it. But reader thread has come first by obtaining the log, and it is waiting for the reading, but there is nothing, right? And the writer's thread is waiting for the log that's not released by the reader. So reader is just waiting, right? So that means the reader will now starve. The writer can write, but reader is not releasing the log. So in a synchronized environment, there is always a problem of starving. So same is the case with the producer consumer problem. So producer has to produce it, then consumer has to consume it. But consumer has obtained the log and it's there to consume, but there was nothing. So now it has to starve, and producer can't go and produce things because it has no log, and no log is obtained or held by that particular consumer. So now clearly there is a communication that is required for these threads for that particular critical section. So whenever reader or the consumer finds that there is nothing to read or consume, they should actually release the log by saying something. Then when they release, here the writer or the producer should come and write or produce, and then these threads should notify the waiting thread that the task has been completed, right? So this is inter-thread communication. So in order to do that, we have three methods actually: wait, notify, and notify all. In fact, wait has two more variants. So total 5 methods are there for inter-thread communication: wait with indefinite time, wait with milliseconds, wait with milliseconds and nanoseconds, notify, and notify all. Okay. So in cooperation, what is happens? It's a mechanism in which a thread is paused running its critical section, and another thread is allowed to enter in the same critical section to be executed. It is implemented by following methods of object class, and these 5 methods, 3 wait methods, notify and notify all, will actually ensure this communication will happen. Okay, so let's now understand about wait methods and others. So whenever a wait method is called, what happens? The current thread, whatever actually executing the critical section, will release the lock and waits until the other thread notifies it. Okay, by using notify method or notify all method. Okay. Yeah, otherwise this thread is actually calling the wait method with some time. So wait of 1000 milliseconds or wait of 2500 milliseconds. So this will wait till the time expires, right? Since we have a different variants, right? So indefinite means till it gets notified, and time wait with some specific time means till the time gets expired, right? So whenever notify method is actually called, the waiting threads on that particular critical section will be notified, and one thread will get selected for execution, right? So with the help of wait and notify methods, this inter-thread communication will happen. So in order to deal with this, I have a scenario. So let me explain the scenario. Yeah. So the scenario is going to be like this. Yeah, I have written actually one scenario. I will explain that. So what is inter-thread communication? It's a communication between threads in a synchronized environment. Only when there is a synchronization, this is applicable. And there are 5 object methods to be used for this inter-thread communication. So wait indefinite, wait with milliseconds, and nanoseconds, and notify method and notify all. Notify method will wake up the object which is waiting on that monitor. Notify all will wake up all the objects which are waiting for that particular monitor or critical section, right? And in order to do this, I'm actually I'm creating a scenario. The scenario is a customer transactions in a bank, right? Customer do 2 transactions, withdraw amount and deposit amount. Both are synchronized things. Okay, so whenever withdraw was asked actually, so some amount will be taken as part of the withdraw. And what we do is, if the withdrawn amount, the asked amount is greater than the balance, okay, so it cannot be withdrawn, right? So now it has to wait for some other thread to deposit. So deposit also deposits the amount. So what is the scenario? So in a customer class in the banking environment, the customer is going to do 2 operations. One is withdraw operation, another is deposit operation. So customer has some balance already. Whenever a thread asks for withdraw and it checks whether the balance is there or not. If the asked amount is greater than the balance, we cannot withdraw, right? We cannot withdraw. So then what this thread will do is, because it's not able to withdraw and it has the lock, and deposit method, other thread is there which is ready to deposit, right? And it withdraw method, the thread which is acting on withdraw has acquired the lock, and it could not able to withdraw because balance is less. So now what it will do, it will actually calls the wait method. That means it releases the lock and it will be waiting for notification. So whenever it releases, the other thread which wants to deposit the money will actually deposits and notifies. When it notifies, the thread which is actually waiting at that particular point will continue its execution, right? Like that, these threads will communicate. Okay, so for that I have a scenario over here. So public class customer, and here I have a balance, and in order to set the balance, I have actually one constructor, and in order to get the balance, I have a get balance method. So this is just like one setter and getter kind of stuff. Now I have 2 methods which are actually synchronized methods, right? One is the synchronized void withdraw, because inter-thread communication will happen only in the synchronization. Only when the thread takes the lock and goes. And after completion, when this locking protocol is being implemented, so this inter-thread communication is required. Otherwise, starvation will happen, right? So I have a synchronized method withdraw, and withdraw method takes an amount, and whenever you enter into withdraw method, it says going to withdraw. And if the amount is greater than balance, the asked amount is greater than balance, so withdraw cannot happen. Less balance. Now what should happen here? So anybody who come over here, any thread, it should actually wait for the deposit. So now wait method we are calling. So wait method can be interrupted. So it throws interrupted exception. So we are keeping wait method in try catch. Okay. So now it waits. Whenever it waits, what happens? The lock is available to other thread. So what the other thread is going to do is, other thread actually waiting for this deposit method to carry out. Right. So whenever it says wait, the lock is available for other thread, it comes over here and takes some amount. It says going to deposit and adds the deposit, and it says deposit completed, and we can check the balance, and finally this is notified. This is the ITC thing. Okay, this is what ITC things, the thread communication. So whenever it notified, so the thread which is actually waiting over here, okay, will get notified. So then it awakes and it continues actually. So now what it will do, because it's now deposited and it is notified, so now balance equal to balance minus amount, and withdraw was completed. So earlier withdraw was not happening, it is waiting. Another thread comes and actually deposits the amount, and then it can actually complete the withdraw successfully. So this is the scenario. right? So in order to explain ITC, I have created this scenario where two threads, one thread is actually calling withdraw method, another thread is calling deposit method. But first withdraw method will come, so it takes the lock, but there's no amount to withdraw, so it waits. That means it releases the lock and waits, and when other thread comes and deposits the amount and it notifies. So only one thread is there which is actually waiting. So that thread is notified and it continues its deposit actually. Okay, so this is actually my business class, and here is my main class. So here what I'm doing, I'm making things simple here. I require two threads. Firstly, I'm creating a customer object with 25,000 actually. Customer object was there with 25,000 as a balance. Now, what I'm going to do is I'm going to create anonymous inner classes, and this time I'm going to create anonymous objects also. For anonymous inner class, I'm going to create an anonymous object and I'm going to start it. So this is the simplest way. So what I'm doing, a new thread. See, here I am not pointing with a reference. So that's why anonymous object. For the anonymous class, this is my anonymous class. For this anonymous class, an object is going to get created and it is getting started. So new thread, that means this anonymous class extends this particular thread class and overrides this run method, and it says c1 dot withdraw of 30,000. So c1 object is there, c1 dot withdraw 30,000, but 30,000 is there in the account? No, 30,000 was not there, only 25,000 was there, right? So that's why what happens here, when it goes, it finds that amount is 30,000, balance is 25,000, less balance waiting for the deposit, it calls the wait method. When it calls the wait method, there is other thread. This is the other thread. So this is the behavior and the class definition, which extend the thread class, and this is also anonymous object. So I'm not having any reference. So now what it will do, c1 dot deposit and start. So it calls the deposit method, and this thread we are starting. When we start, what happens, it is earlier waiting for the lock because lock was there with this thread. Now this thread actually now gets the lock because thread 1 was called wait method. Now it goes and deposits another 25. So total balance will be 50,000. So now here what happens, it goes, it says going to deposit, and balance is updated and deposit completed, and you can actually see the get balance. After that it says notify. Whenever it is notified, what happens, it is waiting over here, we continue its activity. So this is how inter-thread communication will happen. So here I am creating anonymous sender classes and anonymous sender objects. Otherwise, I need to create two separate classes and I need to create the objects of them and I have to call it. Okay, so most of the time we will use anonymous sender classes for multi-threading. It is easy, right? Rather than writing a separate class and creating object, you can always create anonymous inner class object that extending the thread class. And if you wish, you can create anonymous objects also and straight away say start. So this is this competes for the run method, and this also competes for the run method. Whichever goes first will get the lock, the other one has to wait, right? So if this one goes first, it has to wait for withdraw to finish. So here I am establishing the inter-thread communication. Okay, so when this finishes the job and notifies, then it continues its activity. So let me actually compile and save both of them. Yeah. So first one is Java C customer.java. It's taking some time for compilation. Yeah, it's compiled. And then let me compile ITC demo.java. So here I have my anonymous sender classes. Okay, so it's also compiled. Then let me run actually. Now let's see what happens. So first thread, withdraw thread will go, and what it is doing, then it calls the withdraw method. So now going to withdraw, then it finds that there is a less balance because we asked for 30,000, balance is 25,000 only. So now it calls wait method. When it calls wait method, it releases the lock, right? So now this thread, the other thread which calls deposit method will goes there and it says going to deposit, and it says deposit completed, and get balance, it will actually show now the balance is 50,000. Since balance is 50,000, so we can withdraw now, right? So now here it continues, balance equal to balance minus amount. So 50,000 minus amount asked is now 30,000. So you will have 20,000 as a balance and withdraw completed, right? So this is how threads are communicating with each other with the help of these methods. The methods which are actually defined here in object class, the superclass of all Java classes, we have 5 methods. Okay, and yeah, so this is the scenario and this is the main class, and here I am using anonymous inner classes with anonymous objects. So you want to make not anonymous, you can say thread t1 equal to new thread, and later you say t1 dot start, here thread t2 equal to new thread and t2 dot start. That's also can be done. So hope you have understood this. So this is about inter-thread communication, and this is the last topic of multi-threading. So hope you have understood the whole of the multi-threading. So we have started with the basics of multi-threading, where we are discussing what is thread, what is process, and what is thread life cycle. Then what are different ways to create thread by extending thread class and by implementing the runnable interface. Later we understood about some of the important methods like sleep. So how to give uniform access to all the threads, and then join method, some sort of prioritizing, and current thread method, one of the useful methods where you can actually find out what's actually happening, which thread is being run, right? And get name, set priority, get priority kind of methods. And later we discussed synchronization and what is the use of synchronization, how to prevent thread interference, and how to achieve consistency. We have 2 examples. And finally, inter-thread communication. So in a synchronized environment, how threads are actually communicating with each other with the help of the object class 5 methods. So hope you have understood. Thank you.